Robinson-Grabiel synthesis. Robinson-Grabiel synthesis. So when this according to Robinson-Grabiel synthesis, N-acyl alpha acyl amino ketone, alpha acyl amino ketone. Acyl amino ketone, alpha acyl amino ketone in presence of acid medium, in presence of acid medium. So in presence of acid medium, here the bond shifting takes place like this and shifting towards the oxygen side. Then the product is OH in double bond OH. Now it is involved in loss of water molecule, then forms oxazole product will be formation takes place. From second synthesis from isocyanides. From isocyanides. When isocyanates reacting with N-butyl lithium, lithium abstract the proton from here, benzylic position, abstract the proton from benzylic position, then CH minus N positive, triple bond, carbon negative. Now it is reacting with the acyl chloride. Now it is reacting with acyl chloride. Now it is reacting with now it is reacting with acyl chloride. Now reacting with acyl chloride. Now reacting with acyl chloride, then phenyl, C double bond O, CH3, N plus OS minus. It is attacked here. And then the product is cyclation will be takes place here positive. Now it is involved in loss of proton. The product is this is one method. Second method is from haloketones and formamides. Haloketones and formamides from haloketones and formamide, right? That is Berdrich reaction when amides reacting with alpha haloketones by loss of HX upon heating, by loss of HX upon heating, so then the product is R double bond O, R dash O and NH H. This will be formation takes place. So that means first it is amide undergo amide undergo isomerization like this. Now it is involves in loss of HX. Now it is in loss of HX. Then it is undergo. Now it is undergo enol. Now it is undergo enol. Now it is undergo enol. This enol involves in loss of water molecule, loss of water in presence of acid medium, loss of water molecule. Then forms. This is the product R dash R. So method. Next one is reactions. Oxazoles are weak base. Their salts are unstable. Electrophilic substitution reactions takes place at fifth position. Electrophilic substitution reactions. Bromination takes place at fifth position in BS. The special reaction, bromination takes place fifth position, and reacting with mercuric acetate. Mercuric acetate then produces mercury OAC. This is the reactions. Next one is reaction with nucleophilic substitutions. Reaction with nucleophilic substitutions. Nucleophilic substitutions. When halogen at second position, when halogen at second position, when halogen at second position, nucleophilic substitutions are takes place. Nucleophilic substitutions are takes place. Replacement of halogen by different nucleophiles. When reacting with alcohol or phenols, so this will be product will be formation takes place. Next one is next is oxazoles. When oxazoles reacting with the 2, 4, 5 trisubstituted oxazole, 4, 5 trisubstituted oxazole, when reacting with ammonia, simply loss of water molecule, instead of oxygen place, nitrogen is substitution takes place. Instead of oxygen place, nitrogen is substitution takes place. Next, metallation. Metallation of oxazoles takes place at second position. Metallation of oxazole takes place at second position. When reacting with phenyl lithium base abstract the proton from here, and metallation takes place at second position. These are the reacting with this is a nucleophile reacting with any electrophilic center. So any electrophilic center reacting with DMFN and dimethyl formamide DMF. This is a DMF. Formylation takes place. Formylation takes place here. Second position, and this is a condition. So next one is pyrojoules. Next one is pyrojoules. This is a pyrojoule. 1 comma 2. First 1 2 position. A nitrogen containing unsaturated fiber member ring is the pyrojoule. The synthesis of pyrojole. Synthesis of pyrojole. When 1,3 dicarbonyl compounds 1,3 dicarbonyl compounds reacting with hydrogen hydrate 1 comma 4 dicarbonyl 1 comma 3 dicarbonyl compounds 1,3 dicarbonyl compounds reacting with hydrogen hydrate it is involves in loss of 2 moles of water molecule. Now it is undergo then produces pyrojole or the product will be formation takes place. So next one is alpha beta ethylene compounds with hydrogen. Alpha beta ethylene compounds hydrogen. When these compounds reacting with hydrogen, first it is undergo condensation reaction by loss of water molecule. By loss of water molecule. Now it is undergo Michael addition reaction. Then the products are pyrojoles are the product. Next one is from alpha halo, alpha beta unsaturated carbonyl compounds and hydrogens.
Sir, what is the Michael addition, sir?
Hmm. Here.
Addition.
Here, alpha beta. So addition of nucleophilate beta position of alpha beta unsaturated compounds, then double bond shifting takes place. This is Michael addition reaction. Attacking it this with respect to this one, this is alpha beta. So attacking it beta position, negative charge attacking it, lone pair attacking it beta position, nucleophile attacking it beta position. Michael addition reaction that one. When alpha halo, alpha beta unsaturated carbonyl compounds with hydrogens. This is alpha halo, alpha beta unsaturated carbonyl compounds with hydrogen. It is involves in loss of water molecule. Then here lone pair of electrons if this hydrogen shifting here, then ring formation takes place. Here chlorine and phenyl like this. Now it is involves in loss of HCl, then forms This is the product will be takes place. Next reactions. NH-free unsymmetrical pyrazines exhibiting tautomerism. NH-free pyrazoles existing in tautomerism. Next reactions. These are existing in tautomerism. These are unsymmetrical pyrazoles, unsymmetrical pyrazoles existing in tautomerism. Then the bond shifting takes place here to here. The bond shifting takes place. So next, N substitution, pyrazole undergo N substitution reactions. Pyrazoles undergo N substitution reactions when pyrazole with a free nitrogen when reacting to Grignard reagent RMGX, then MGX, then nitration, nitroso derivative, and reacting with secondary amine, formaldehyde, HCl, manage reaction, aminomethylation at active CH position, manage reaction. These are the some examples for N substitution reaction. Electrophilic substitution reactions. Electrophilic substitution reaction takes place at C4 position when reacting with chlorine or bromine halogenation at fourth position, and nitration HNO2, HNO3 and H2SO4. NO2 and sulfonylation oleum. So these are the electrophilic substitution reactions at um, C3 position. Next one is nucleophilic reactions. Nucleophilic reactions. Nucleophile attack at C3 or C5 position in pyrazole. C3 or C5 position in pyrazole. Nucleophilic substitution reaction. Nucleophilic reactions at C5 position, C3 or C5 position when reacting with n-butyl lithium, minus 70 degrees Celsius. Then lithiation takes place at C5 position. Lithiation takes place at C5 position. Now this negative charge reacting carbon dioxide followed by hydrolysis, carboxylic acid is introducing it here when we take n-butyl lithium Negative charge, this negative charge, no lithium. This lithium here bond will open the ring takes place for Cl. This is the product will be formation takes place. Next one is imidazole. Imidazole. Imidazoles. Now synthesis of imidazole from 1, 2 dicarbonyl compounds with ammonia, 2 moles of ammonia and aldehyde. So by loss of water molecule, 3 moles of water molecule then forms imidazole is the ring will be formation takes place. Imidazole ring will be formation takes place. Imidazole ring will be formation takes place. Mechanism for this reaction: when 2 moles of ammonia condensation with the carbonyl compounds by loss of water molecule, 2 moles of water molecule. Now it is reacting with aldehyde. This aldehyde also involved in loss of water molecule. Then the product will be formation takes place. Next one is alpha haloketones and amidins. Alpha haloketones and amidins. Alpha haloketones and amidins. Alpha haloketones and amidins. When alpha haloketone reacting with amidin by loss of HBr, here by loss of HBr, here by loss of water molecule, by loss of water molecule, then forms amid, then forms imidazole is the product. Imidazole is the product will be formation takes place. Imidazole product will be formation takes place. Next, same from alpha hydroxy ketones. From alpha hydroxy ketones and amidins. It is involves in loss of 2 moles of water molecule. It involves loss of 2 moles of water molecule and then forms now it is here that hydrogen undergo shifting takes place. So imidazoles are the products. Next one is properties. NH free imidazoles are amphoteric, acidic due to the pyrazole nitrogen and basic due to the pyridine nitrogen. These imidazoles are act as a amphoteric, means acidic and basic. Due to the presence of this free H, it is act as a acidic. Due to the presence of pyridine nitrogen, it is act as a base. So it is these are existing in tautomerism. These are existing in tautomerism forms. So these are the existing tautomerism forms. Imidazole existing in tautomerism forms. The hydrogen shifting takes place. So existing tautomerism forms. Next one is formation of salt. Formation of salt. When this imidazoles reacting with HX, salt will be formation takes place due to the acidic basic nature. Due to the basic nature of the pyridine nitrogen, they forms salt. They form salt. Next one is due to the free hydrogen act due to the free hydrogen reactions, it is act as acidic. Due to the free hydrogen, it is act as acidic. Therefore, the reactions on free NH hydrogen, when it is reaction takes place, secondary amine formaldehyde HCl. The product is amino methylation takes place like this only. So if it is we take alpha beta unsaturated with the carbonyl compound cyanates undergo Michael addition is possible. Reaction at second position. Reaction at second position. Metallation. Metallation. Reaction at second C2 position. That is metallation. Metallation. That is when reacting with substitute N substituted N alkyl substituted imidazole reacting with N butyl lithium. So metallation takes place at second position. It is reacting with carbon dioxide, water. Carboxylic acid will be formation takes place. Electrophilic substitution reactions. Electrophilic substitution reactions takes place at C4 position. C4 position. Electrophilic substitution reaction take C4 position. Nitration. Trinitroimidazole. Sulfonation. These are electrophilic substitution reactions. Nucleophilic displacement reaction. Nucleophilic displacement reaction. Halogen at C2 position. Nucleophilic displacement reaction is possible. Halogen at second position. Arrangement second question, nucleophilic displacement reaction is possible when secondary amines, we take secondary amines, nucleophilic displacement is possible. Next, isothiazole. Next one, isothiazole. Isothiazole. Isothiazole is isothiazole. Synthesis of isothiazole from first one is from nitrile sulfides. From nitrile sulfides. From nitrile sulfides, when nitrile sulfides when it is involves in ring opening, upon heating by loss of carbon dioxide, then produces nitrile sulfides. These are the nitrile sulfide. This nitrile sulfide reacting with acetylene derivative, these undergo 1,3 dipolar addition reaction. 1,3 dipolar addition reaction. The product is S. The product will be formation takes place. Isothiazole product will be formation takes place. Next, from isoxazole. When isoxazole reacting with hydrogen nickel, reacting with P2S5, now it is undergo loss of, in presence of iodine, loss of hydrogen, then forms isothiazole is the product will be formation takes place. Next, reactions. Electrophilic substitution reactions. Electrophilic substitution reactions. Electrophilic substitution reactions take place at C5 position. Electrophilic substitution reaction takes place at C4 position. Sorry, electrophilic substitution reaction takes place at C4 position. Okay. Therefore, isothiazoles, when reacting with nitration, undergo nitration reaction. Nitro undergo oleum sulfonation. Like this will be product will be formation takes place. Nucleophilic displacement reaction. nucleophilic displacement reaction. Halogen at C5 position undergo nucleophilic displacement reaction. Halogen at C5 position undergo nucleophilic displacement reaction when reacting with primary amines. This is a nucleophilic displacement reaction. Metallation takes place at C5 position. If C5 position is black, metallation takes place at C3 position. Okay, metallation takes place C5 position when metallation C5 position when reacting with alkyl lithium, then at C5 position, this C5 position, negative charge at lithium positive. It is reacting with bromine. Then the product is bromination takes place. If metallation at C3 position, if metallation at C3 position, metallation at C3 position causes ring opening. Metallation at C5 position, C3 position, it causes ring opening. Causes ring opening. Ring opening. Photochemical reaction. Reaction. Isoxazole to isothiazole to thiazole. Isothiazole to thiazole. When isothiazole to thiazole, when it is involved in presence of photochemical condition, in presence of photochemical condition, the lone pair of electrons on sulfur attack it here, and the pi bond shifting to third position and shifting to fifth position. Then that is need to charge it here. Now it is involved in ring opening. Now it is involved in ring opening. The product is, so this is a isothiazole to thiazole, isothiazole to thiazole. Next one is thiazole. This is a thiazole. First synthesis. Synthesis is from isothiazole upon photochemical condition, then produces thiazole. This is isothiazole to thiazole first. Second one is alpha halocarbonyl compounds. Alpha halocarbonyl compounds with thioamidines. Alpha halocarbonyl compounds with thioamidine. It is involved in loss of under heating. It is involved in loss of water molecule, loss of HCl. Then that product is or C double bond O, yeah, S, NH. This is undergo nucleophilic addition carbonyl carbon and the carbon pi bond shifting towards oxygen side. Then the product is OH, S, N double bond H. It is involves in loss of water molecule. The product is, this is the product will be formation takes place. The azole will be formation takes place. Next one is order synthesis, gradual synthesis, gradual synthesis. Then gradual synthesis is alpha acyl amino ketone. Alpha acyl amino ketone. Alpha acyl amino ketone in presence of P2S5. In presence of P2S5. This one of the ketone oxygen undergo sulfonylation. The ketone oxygen is replaced by sulfur group. Now it is involved in loss of water molecule. Now it is involved in loss of water molecule. Then forms then forms the product will be formation takes place. Next one is reactions. The azoles forms crystalline salts with strong acid. Triazole forms crystalline salts with acids, strong acids, quaternization. Next one is electrophilic substitution reactions. Electrophilic substitution reactions. Electrophilic substitution reactions takes place at C5 position. Preferably it takes place at C5 position. Preferably it takes place at C5 position. Bromination with the bromine in acetic acid or bromine in NBS. Bromine and H2SO4, HNO3, nitration at fifth position will be takes place. Like this, electrophilic substitution reactions takes place fifth position. Nucleophilic substitution reactions. Nucleophilic substitution reactions. Halogen at C2 position undergo nucleophilic substitution reaction. Halogen at C2 position undergo nucleophilic substitution reactions. When reacting with thiophenol, the halogen undergo nucleophilic substitution reaction. When it is reacting with sodium methoxide, methoxy will be formation takes place. Next, photochemical reaction. Under photochemical condition, the ring is opening takes place. sulfur atom. The ring is opening takes place. Takes place, attacking here, rearrangement takes place, then the product is so this reaction. Next, desulfonation. Desulfurization. When reacting with hydrogen in presence of nickel, the ring open takes place and sulfur atom is elimination takes place. So this is the uh, thiazole. Thiazole. So this is the topics of this is today the topic of uh, five-membered heterocyclic compound containing two heteroatoms. Five-membered heterocyclic with two heteroatoms. Thank you. Next class we are meet.